Okay, so we are moving for drawing a new drawing sheet of the assembled component. So we have to select file, new, again three options will come here. So part has been drawn, the 3D parts, all 3D parts have been drawn, assembly of all the 3D part has been done. After that we can go for drawing the drawing sheet. Okay, so click on the drawing. So first thing we have to select is a drawing sheet format. Okay, so it is possible to create our own drawing sheet format. Okay, so that time we can create your own defined drawing sheet format. But for example, I'm taking here A3 and C landscape. So we choose A3 landscape having width and height defined. So this is the drawing sheet. If you want to edit some details in this, we can go for edit sheet format. So once you click on this document will become editable. So once this sheet is open, there are different environments like we have seen parts and assembly. So this is view layout. In this environment, we can add different views according to our requirement. In this, we can add different dimensions, letters, and different symbols according to requirement. Also, one of the important thing is we can add bill of material directly from the part list. Okay, so part list can be generated automatically in this. Also, there are sketch options on this drawing sheet. If you add some sketches, you can add using this sketch option. So this is another additional advantage. The part which are not available in the assembly and you want to sketch, you can directly sketch on this drawing sheet also. Some corrections. These are some advanced tools which we are not going to do. Important tool is these two one. First is view layout and then annotation. So first of all you have to exit the sketch to make these things on. Then next part is, so next we have to select on the model view. Okay, once we click on the model view, this window will open. So click on the browse. The browse, we have to select which assembly view we want to see. So this is the my drawing. Let's function drawing. We can draw different views from that like this. You can draw isometric projected views. Like this you can draw different views. This to make it stop, click either escape or OK. So these are different possible views we will get from the model view option. Out of this we have to select which is required and you have to delete which is not required. So in this view isometric view is not easily visible. So I can delete this. In this view, since object is cylindrical, both the views look same. You can delete one of it. Similarly, front view and side view, since object is cylindrical, same. Okay. So we want 4 different views. One of view will be top view, one of view will be the front view, one will be the sectional view, and one view will be the isometric view. Okay. So once you click on any views, okay, this is the drawing view toolbar you can see. Okay, in this we can change the visualization like this. We can make the hidden lines on, we can make hidden lines off. Okay, so I click this. Now I can see the hidden lines are on for these two views. Okay. Again, we can increase the scales using custom scales. In the custom scale, based on the dimensions, we have to make this sketch is appropriate size with respect to this A3 size sheet. So user defined make the dimension 3. So all these 3 views are getting enlarged. Okay. Since if it is okay with me, I can make this okay and I will go with the next operation. So scale is dependent on the dimensions of the object to be drawn. Okay. So this scale may be different for the next drawing. Okay. So it is user defined completely. Then next part is, so this is about making the visualization and adding the scale. click OK. The next part, if you see, there is a projected view. Most of the times we need a projected view. So if you select any view, from that view you can generate different projected views. So these options are not available with AutoCAD, but due to the advanced software like SolidWorks, okay, we can draw projected views. So there is no need to draw front view separately, top view separately. From 3D drawings, we can extract all three views in orthographic project. Okay, next part is a sectional view. Okay, we can draw sectional view from the any given or available view. For that, first we have to select any view, then click on sectional view, then I have to define a sectional plane. Okay, since already one subject, sectional view. We have to define for sectional plane. Okay, like this, we can create sectional plane. Okay. So this is about drawing a sectional view. Next part is detail view. So in this detail view, okay, we can describe a detail about any drawing. Okay, like this, curve or critical operations is necessary that time. We can add this detail view. This is important in case of particular specific operation. So we require 4 drawings, out of which one drawing will be front view, one will be the top view, one is sectional drawing, and another is the isometric drawing. Okay. So we can define its scale according to our requirement. Okay, after the view layout, next part is the annotation. So in the annotation, we can see some similar symbols like sketch commands. First thing is smart dimension, another is plane mode. Okay, all these things. So first we'll learn how to view the dimensions. So first, if you select any object and then click on smart dimension, there is an option called the auto dimension. So in this auto dimension, you can directly give the dimensions required for any particular view. Okay. So for example, we have selected this view. In this particular view, smart dimension, and that auto dimension. The auto dimension only selected entities. So this entity I have selected. Make it okay. So all the dimensions in that particular view is visible. So now it is our job. The dimensions which are not relevant, that we have to delete. Suppose this distance between linear distance between these two circles, that is not needed. So we can remove that dimension. So dimensions which are required, only that dimension is to be kept. Others can delete. For example, this view contain only circles. So all the dimensions related to diameter only you can keep. Rest dimensions you can delete it. Okay. So you have to edit this first. Okay. So that the drawing will look decent. Okay. For the dimension. Again, the dimensions which are repeating, we can delete that also. Okay. We have to define which dimension. Okay, like this, we can add dimensions for each and every one. Smart dimension, auto dimension. For selected entities, this is the entity select. This is the entity select. And to click OK, it will define all the dimensions. Dimensions again, there are all the dimensions defined, but we don't require this much. So one more option for this is the basic option. Go for the smart dimension. You can define the dimensions from here. So this is also a quick process rather than deleting all the dimensions which are not required. You can directly go for the dimensions which are required. You can directly give the dimensions from here. Okay, so have practice of both. So I will suggest use smart dimension and give the dimensions manually rather than giving dimensions. Also you can use readers for showing there are 6 number of holes as given as in your given drawing it is given like there are 6 numbers of holes of decimal diameter and decimal PCD like that you can write here, okay, by using reader option. So this is about giving the dimensions. All the dimensions can be specified. Okay, give the dimensions in such a way that the dimensions are distributed in each view. Okay, some dimensions are going to be visible here, so give that dimensions here. Some dimensions are going to be visible here, give that dimensions here. Some will be visible here. Isometric view does not have any dimensions, so don't give dimensions here. Also, no hidden lines in the isometric view. The next is the A note. Okay. In this A note, we can add a text. So here we can add a text using A note. Suppose the name of this view is now left hand sectional view. LH now this is not visible. You can increase its size. You can place it wherever it's required. So all the lettering part can be done using A note option. Okay. So each view will have each will have its name. Like this is the front view, this is top view, this is left hand side, this is isometric view. One more thing is that you have to add a note of all dimensions are in millimeter. All dimensions are in millimeter. Okay. Same thing we have done in editor. This you have to add note here. This is about giving lettering. Next part is identification of part. Okay, so if you see our drawing, in the final assembly drawing, each part is identified with one number like this. Can you see this? This is called as a balloon. Okay, 1, 2, 3, like this. It is identified, and then each part number is related with that name and material and quantity. Okay. So like this, we can add balloon. This is called as a tolerance symbols. Okay. So this also can be added using these options. Okay. So here options you can see the geometric tolerance. This also can be defined. We can define surface finish also. Okay. So surface finish symbol, this is called as a surface finish symbol. So this can be also given in this drawing. Okay. So you have to what you have to do, you have to give balloons as it is given in this. Not necessarily exactly it looks, but it should include all the balloons and particles. So first we will include the balloon, then we go for the particles. So we have to approach to the balloon in a particular view in which the particular object is visible. Like bolt is visible here. Okay, nut is visible here. Body is visible here. Okay, it should look decent. It should not look like it should not avoid the view of a diagram. Since neck bush and blind bush is not visible, I will give the balloon width here. Okay. So 1, 2, third part is missing, third part is grand. 1, 2, 3, 4, 5, 6, 7. So you must ensure that all the parts have been given number. So this is called numbering in balloon. Okay. The next is generating a bill of material. Bill of material will include number of parts, type of material, and its name. Okay. So if you want to create any bill of material, you have to select one view. Okay. So click OK. Okay, so once the part list is generated, these are the things we can visible on this, can be visible. First is number of parts. There are 7 types of parts are there. The name is taken from the name which I have given for that particular part file. So have a habit to give name in capital so that it will also appear in this table as a capital letters. Then description or material. Okay, so this you have to add. This you have to add by keeping at this initial level it will be blank, nothing. For example, for gland you want to enter the material, enter kipling, and now you can enter the material like a brass. Okay, quantity is getting automatically calculated from the drawing or particular drawing view. Okay, so there is no need to add the changes here. The only thing to add is you have to add the material. So this is the automatically generated part list. Okay, the same part list can be generated in the SolidWorks by just clicking the one view. This is the table or generating the part list using table. Okay, so I think almost all things have been covered. First, we have started from selecting the views. So we have to decide which types of views we require. Then we have given the dimensions to each the view. Okay, we have 2 ways to give the dimension is auto dimensioning and smart dimensioning. So use smart dimensioning and manual way so that you can define the dimensions as you want. Then we have drawn the sectional view. After that we have given numbers to all the parts using balloon option. Then we have generated this part list or bill of material. Okay, so I think almost all things are covered here. See, this is the uh, total travel from 2D sketch to 3D part, 3D part to 3D assembly, and 3D assembly to 2D drawing sheet. Okay, so same path will be followed for all the rest of the drawings. Okay, only thing the type of sketch will going to be a different one. Okay, the rest the procedure is same in all. Okay, just some commands will be here and there, but rest of the process is same. You have to create for 2D sketch, then you have to create separate 3D parts, then you have to assemble all the 3D parts, and then assemble 3D parts. You can create a drawing sheet. Okay, so this is all the things you have to understand while using the SolidWorks modeling and drafting. So next will be the tutorial for assembly of hook step bearing. Okay, so I suggest whenever I am operating for any tutorial, you must have hard copy of this drawing so that you'll be able to match with the speed of video tutorial with respect to the dimensioning I am giving. Okay, since I am also referring this hard copy, you should also refer the hard copy since it is not easily possible for referring soft copy and giving the dimensions in the SolidWorks. So always have hard copy in your hand and then you can watch these video tutorials. Okay, I think all things are cleared up here. Okay, so we'll go to the next tutorial.